Point Clouds 101. Yeah, that's me. 35 years and going, apparently, of which nearly 30's been with Lee. So, as they say, you get shorter jail terms for murder. So, and based on some of my demos, instead of the cutting edge of technology, it's certainly the bleeding edge. Point clouds, what are they? Is that coming through okay? Or am I? Okay, that's better. That's a picture of a typical point cloud. I think in there's about 10 million points just in that little bit of an intersection. So basically it's a swarm of points. These points have no relationship to each other. They're just, you can almost consider random points. Okay, so that means a point that's 5 millimeters away from another point has no idea how close or far it is. There's no connectivity like a line string or a tin or anything. It's just, as Lee has said a few times, I believe, just really dumb data. Unfortunately, point clouds can now be gathered by all of these current forms. In case you don't know, with Android, now with a phone, we can walk around Blake's head there and scan his head just off a phone. Total stations, dedicated scanners, fixed locations, mobile scanners, drones and aircraft. So the technology for gathering this data is very broad, which makes it you can't ignore it. And they can go from a few points, like thousands, to billions or trillions. I think at the last conference, I think I had, was it 32 billion points in one job there? I think if I was to ask the same customer for that data now, it would probably be 100 billion points, because the densities of what some of these scanners can collect data at is just growing exponentially. I mean, some scanners can do 10 million points a second. So if you had a scanner in this room and it spun around for 10 seconds, you'd have 100 million points just in 1 minute. So we've got a problem. Engineers and surveyors once used to think having 10,000 points for a design or something, wow, that's really great. We've got all the data we need. Now you could have 1 billion points. What does that mean? They may look intelligent, and that's only because the eye is connecting all the dots and the color of each pixel, of each point of the cloud to form a picture in your brain. Unfortunately, the computer is not the visual cortex of our brain, so it has a very different view of what this data is. It's just something that's really big on disk. It's really painful to traverse through a terabyte of data, because as you know, a terabyte of data, if you were to copy it from your computer to a USB drive, what are we looking at, Blake? A couple of hours? A couple of hours of time just to copy from disk drive to disk drive. So that's the magnitude of the problem that's facing us. So some people utopia, some people a nightmare. The people who haven't used it yet, it looks like utopia. The people who have used it, they're beginning to think it's a bit of a nightmare. And I think I could name a few customers here who have had some interesting point cloud stories. I'd love to bring them up and share it, but apparently I've only got about 4 minutes left. So I may not even get to my demo yet. So is it a solution looking for applications? Unfortunately, pretty soon everyone will be able to create point clouds. Even your kid with his phone will be able to do it. It's a disruptive technology for everyone, not just surveyors. So we all have to adapt or die on this one. So what can we say about point clouds? Sorry, you're not going to like the answer. You're really not going to like it.
Well, you're really not going to like it. Tell us. The answer to the great question, yes, of life, the universe, and everything, yes, is 42.
Honestly, every time I see that now, I think of point clouds. So the question at hand for all of us here today is, well, what's happening in 12D model? Well, we developed our own point cloud engine. We looked at third-party engines. We even tried a few of them, and once they were less than impressed, but we realised we were going to have a very special requirements for what we needed to do with point clouds, which was a very different vision from what these third-party packages were offering. Nearly all of them were offering, yeah, look, you can look at all these points. And that was it. We go, well, we've got to process these points. We've got to find functionality that's actually going to do something real for all of our customers. So we ended up with a point cloud is just a string in 12D model, albeit a very special string which normally strings reside inside the dot model file. In this case, the point cloud string actually references another file inside of the dot project called a dot cloud file. And it means if you have 1,000 point cloud strings within the one model, that model itself might be only a couple of kilobytes, but it could be pointing at 1 terabyte of information. And that gave us a lot of efficiencies that otherwise just weren't available to us. So, being a string, it meant just about every option in 12D should work for a point cloud string. It may not go necessarily quick if it's a terabyte of string data, but so Peter Murray, if you're writing your macros for 1 billion points, good luck. Can I? All right. Can you hear me? All right. So I'm going to start a little demo here. I guess this is probably... So as mentioned in the presentations this morning, you know, we've added a lot of extra new formats for predominantly the Leica series. I mean, they seem to be breeding like rabbits, all these formats, despite the fact there's the old joke of there's 31 competing standards out there for a point clouds. So let's go make a new standard. Now we have 32 competing standards. Haven't you heard that one? Oh. That fell flat, didn't it? So yeah, under point clouds, you know, I think Lee showed this picture. The GeoTIFF one's an interesting one. It's really a grid, but you can consider grids almost like a point cloud. So in Europe, apparently, using image file formats like GeoTIFF or TIFF or JPEG, etc., is very popular for storing grid data. So we have that option there. So the import's all straightforward. I've already done that to save some time because I must be running out of time very quickly. The most interesting part at the moment is under our strings. And so, as Lee mentioned, we've got all this functionality for setting categories and actually editing LAS files on disk rather than in memory. There was a whole lot of different requirements that are coming over time. Deletion of points. The deleting is actually just tagging the point as deleted. Because obviously, if you have a gigabyte file and you're deleting one single line in the middle of it, it's very inefficient to compact the file. So we just don't bother as part of an all operations, which then means it's quite easy to undelete points. So the deletion of points, we have a couple of modes. Oh, sorry, we've only got one mode. At this point, the only one I've done is just by tin. Because what we're finding with point clouds, and I think you probably find the same thing, most operations on point clouds only make sense if you've got something else to compare them against. If they're just a swarm of points in isolation, it's very difficult to do anything with them. And so we came up with this option where we said, well, we've gone and done a scan of a new section of terrain. We have an old tin, which is, let's say it's plus or minus 500 mil within accuracy of what we think it should be. So here we can say, well, let's just set a distance 0.5 plus or minus in this dialog. So let's just go 0.5 and minus 0.5. Well, actually 0.5, actually I don't think it's negative. And if we run that, that will go and actually tag every point outside of that range as being deleted. So instead of picking up trees and and birds flying and overhead wires, all that sort of stuff, it's a relatively quick way of cleaning up data. So I think that's what you're going to find over time with what we're doing with more options inside 12D model will be a lot more options where we're doing operations on point clouds relative to some other form of data. And one of the big ones which our own very Graham Worth kept pushing me for ages was this option, which is the global drape. And I'm actually going to run this option. So I'm going to actually say I want to drape all of those strings on this view here with line marking. And I'm going to do it against, in this case, LAS import. I'll come back to explain importing versus referencing in a second. And I'm going to leave the height blank. And I'm just going to type a new model called, let's just call it Drape 2016. 16. And we'll go let that go. So that's calculating at the moment, and it should crash very shortly. Come on, come on, come on, come on. Now, what I should say is this model here for the point clouds, the reference, it's got, that's only 15 million points. So what we've actually got now is if we go and take this data off the view and add on, what do they call it, Drape 2016, and then let's go and profile that string, that's what we get. So what's happened here is we've actually taken along this string, we've looked to the left and right. Sounds a bit like one of Paul Hardwick's Fix 'em Up macros, actually. Very similar. And so we're just going left and right for an infinite height, finding all the points in that point cloud which pass near this string and creating a 3D string out of it. So this is very handy for taking 2D data, existing data, like in this case line marking, taking a point cloud and 3Dizing the data. These sort of operations are actually much easier to actually make sense of and actually make work. So when you start thinking about point clouds, these are the sort of things you should be thinking about. How can I relate this back to something real world in terms of strings or tins or tri-meshes? So some of the stuff that we've been doing with the tunnels. Point clouds, we're comparing them against the tri-mesh to get relationships that are meaningful. And how's my time going, Lee? That's enough? So yeah, and actually I was going to mention what the difference between on file import, like for example under LAS, we have this concept of referencing or importing. The referencing is purely saying when we import a point cloud into 12D, we're bringing it into our own point cloud format. So if the point cloud is 1 gigabyte in size, our format will end up being a gigabyte, maybe plus a bit. So if you only ever wanted to do spasmodic operations on point clouds, sometimes it's more efficient to say, I'm just going to leave those LAS files sitting up on the server, reference them, and just use them that way. But if you're going to be doing a lot of operations like these drapings and drawing and deleting of points, then the importing is an order or two faster in terms of operations. But you have a disk space consumption cost. So that's the difference there. And then there's a whole bunch of flags for point clouds for saying, I really don't want to draw this point cloud. I don't care what happens, just don't draw the point cloud, just draw the infamous red box. And that's just going to keep happening throughout the lifetime of 12D as we keep getting more interesting settings. So that's it. Thank you.